Hello friends, I am Dr. Lokesh Vashne. Today I will discuss Norton theorem. Previously I have teach Thevenin theorem. Both theorems are almost same. Now come to the second slide. Prerequisite physics, precapitulations, Ohm's law, Kirchhoff current law, Kirchhoff voltage law. Now come to the objective of this theorem. This theorem is especially useful in analyzing power system where system is complicated and other circuits. One particular load resistor is subjected to change and recalculation of the circuit is necessary with each trial value of load resistance to determine the voltage across it and current through it. This theorem is used for DC circuits where the system is linear network containing independent source and resistance. We can use this theorem only for DC circuits. Okay, now come to the next. Now come to the introduction. Norton stated that any linear electrical network containing only voltage source, current source and resistance can be replaced at terminal AB, this one AB, by an equivalent combination of a current source IN, this one IN, in a parallel connection with resistance RN. Here we convert all the circuit except load resistance into a one current source parallel with Norton resistance, and after that we connect the same load resistance where we calculate the current, voltage or power. Now come next. Now I ask again one question: what is the need of this theorem? Why we use this theorem to solve any circuit? You can solve any circuit through KVL, KCL, superposition theorem. Why we use this theorem? I ask this question in Thevenin theorem also. The same answer is that Norton theorems provide an easy method for analyzing power circuits, which typically has a load that changes value during the analysis processes. This theorem provides an efficient way to calculate the voltage and current flowing across a load without having to recalculate your entire circuit over again. Now we understand what I am saying. Here a circuit is given and they ask that calculate the load current in this resistance. This resistance here is called load resistance. You calculate the current flow in the load resistance. We can solve this from KVL, KCL superposition. But here RL is variable. If we solve KVL or KCL for a particular value of RL, we write equation. Now again the value is change of RL. Now again rewrite the equation of KVL, KCL. So if they change the value, then again write the equation. So is a lengthy process. Now on the other hand, Norton theorem, we use Norton theorem. We convert this circuit into a one circuit which have known as Norton equivalent. There one current source and one Norton resistance is there. Means this circuit is converted into one equivalent, Norton equivalent, there is one current source and parallel with one resistance, which is Norton resistance. Now after that we reconnect the load resistance and find the value of any time or any value of RL. It is a very easy method to calculate the flow current in the RL. We know that how the dividation rule of current in any two parallel branches. So we calculate the value of RL. We know that the formula is that if we want to calculate the flow of current in RL, then IL is equals to Rn into In upon Rn plus RL. Now come to how to calculate Norton equivalent. Here we give one circuit. There is two resistance R1, R2, one current source I, one voltage source. We find the current in RL through Norton equivalent. Firstly, you remove the RL from the circuit, and after that you connect the terminal of AV by wire. It means short circuit of terminal A and B. Okay. Now we find the current in the short circuit AB. We find the current across AB, terminal AB. This current is known as Norton current, short circuit current and current AB. Now how to calculate? We use through KVL or KCL. We find the current through KVL, KCL and superposition. Now come how to calculate the Norton resistance. This is very simply, this is same method. You know that Thevenin, how to calculate Thevenin resistance, same as the Norton resistance. The equivalent resistance Rn is the resistance that the circuit between terminal A and B would have if all ideal voltage source in the circuit are replaced by a short circuit and all ideal current source are replaced by an open circuit. That means all sources are replaced by their internal resistance. Here same process is applied. Firstly, we convert voltage source or current source their own resistance. Means voltage source have zero resistance, then it is a short circuit. Current source have their high resistance, then it is converted to the open circuit. So I applied here. Here voltage source short circuit and current source open circuit. Now we see that from the terminal AB, R1 and R2 are in series. So the value of Norton resistance is R1 plus R2. Now come to the Norton equivalent. You put the value of IN which you have calculated and parallel with resistance. This is Norton resistance. You put the value of Norton resistance. This is called Norton equivalent. Now if you find the value of RL, then you attach the RL, connect the RL with Norton equivalent. Always remember, this is a equivalent. This is Norton equivalent. If anybody asks in question, find the equivalent in the given circuit, then you find only equivalent, not connect the RL. Simply IN parallel with RN. Now if they want please calculate the value of IL. So you simply current division rule applied. IL is equals to Rn into IN, total current, upon total resistance Rn plus RL. Now come to the one example. Find the IL in the given circuit through Norton theorem. Here one circuit is given which is purely linear. Linear means resistance and current source and voltage source are there. Here we find the current flow in 2 ohm resistor. It means it is a RL. Now what we do? Now come to the second slide. Firstly, remove the load resistance. Now this circuit is come. We are following step by step. Step 1 is, in order to find the Norton equivalent circuit to the left side of the terminal A and B, we should remove the 2 ohm resistor, which I have said earlier, it is a load resistance. We should remove the 2 ohm resistor from the network by opening the terminals A and B. The modified circuit diagram is given in the following figure. Now firstly, calculate IN. How to calculate IN? Firstly, join A and B, a short circuit A and B through wire. Okay. Now calculate the flow of current in this wire. Okay. How to calculate? I have calculated through KCL. If you want to calculate through KVL or superposition, then you applied it. Here we use nodal method, nodal analysis method. Step 2, calculation of Norton current IN. Firstly, short circuit the terminal AB, which I have said. We can use nodal or mesh analysis method. Here we are using node analysis method. If you want to use mesh or superposition, then you use it. V1 is the voltage. Here only 2 nodes are there, 1 node and 2 node. In the nodal analysis, 1 node is grounding, so we are connected to grounding. Here potential is 0 and this node is called V1. V1 is the voltage from node 1 with respect to ground and IN. And IN is the flowing current in the 1 ohm. This one means this current is known as IN. IN is the flowing current in 1 ohm. Now we find the value of IN. Here we applied the node analysis method. There are 3 branch, 1, 2 and 3. So we are using 3 step, 1, 2 and 3. 3 steps are there. First one V1 minus 3 upon 3, this current. Okay, V1 minus 3 upon 3. Here minus 1. Here V1 upon 1. V1 upon 1. Now we find the current V1. 1 ohm resistance voltage is this one, V1. V1 is equals to 3 by 2. The voltage across through 1 ohm is 3 by 2 volt. Now what is the the flow of current in this 1 ohm? It is, we know that Ohm's law, V is equals to IR. So we find the I is equals to V upon R. R is 1. So V is and V is 3 by 2. 3 by 2 upon 1 is 3 by 2 ampere. The flow of current is 3 by 2 ampere. Here we know that suppose that V1 is a positive and positive value is come. So V1 is positive. the flow of current from V1 to V0. So current flow from V1 to V0 from A to B. The IN is positive. Now come to calculate the value of Norton resistance. Calculation of Norton resistance Rn. Short circuit the voltage source and open circuit the current source, which I have said earlier. All sources are converted into its internal resistance sources of the above circuit in order to calculate the Norton resistance Rn across the terminal A and B. Here always remember, we are not short circuiting, we are calculating Norton resistance, so we are not short circuit A and B. Generally many students short circuit terminal A and B. So remember, we calculate the resistance terminal A and across A and B. Now this circuit is converted into this circuit. Voltage source is short and current source is open. So we see from terminal A and B, what we see, 1 ohm and 3 ohm are in series. So the value of Norton resistance is 3 plus 1, both are in series. So 3 ohm plus 1 ohm is equals to 4 ohm. So Norton resistance is 4 ohm. Yeah, RAB is equals to 4 ohm. Now come to the equivalent. So the equivalent is that we know that the Norton current is 3/2 ampere and Norton resistance is 4 ohm. Both are in parallel. So it comes Norton equivalent. Now we find the load current in load resistance. Now come to the next slide. Here is step 5. Last step is there. The Norton equivalent circuit is added with load resistance. This circuit diagram is shown in the following figure, and find the IL. Here we reconnect the load resistance which is removing. Now we calculate the IL. Here simply current division rule applied. Current is 3/2, IN is 3/2, Rn is 4, and here total resistance. Always remember that here we put Rn because we put denominator side, both numerator side resistance is that resistance where we are not finding the resistance. So opposite resistance we put there. Now Rn into IN upon total resistance. So the value comes is 1 ampere. 1 ampere load current is come here. Now we discuss in second example. Here we calculate the load current in the given circuit through Norton theorem. Here the load resistance is 3 ohm. Here we calculate load current, a flow of current in the load resistance. Load resistance value is 3 ohm through Norton theorem. Firstly, remove the load resistance, which is 3 ohm. Okay. Step 1, in order to find the Norton equivalent circuit to the left side of terminal A and B, we should remove the 3 ohm resistor from the network by opening the terminal A and B. The modified circuit diagram is shown in the following figure. Here we remove the load resistance. Now come in step 2, calculation of Norton current IN. We can use nodal or mesh analysis method. Here we are using node analysis method. If you want to use mesh analysis method, then it's okay, you use it. Here we are using node analysis method. There are two nodes are in the circuit. One node is grounded and other node name give V1. V1 connected 3 branches, so we are using in 3 steps for this branch. The step equation is V1 minus 4 upon 2 for this, V1 upon 2 for second branch, V1 upon 1 for third branch. Here IN in Norton current is flowing in 1 ohm. Here we calculate node voltage V1. V1 is equals to 1 volt through this equation. Now we find current IN. Simply we apply the Ohm's law. V is equals to IR. So I is equals to V upon R. Here we calculate Norton current. Now come to the step 3. In step 3, calculation of Norton resistance. To find the Norton resistance, short circuit the voltage source of the above circuit in order to calculate the Norton resistance Rn across the terminal A and B. All the sources convert into the internal resistance. Here in the circuit, voltage source is given, so we convert the voltage source into its internal resistance. Now we find Norton resistance across terminal A and B. Here we see that 2 parallel resistance, 2 ohm parallel resistance is there, is connected with series 1 ohm resistance. Now we calculate Rn. Rn is 2 ohm. Now we convert all Rn and current source into its equivalent, means Norton equivalent. Now the Norton equivalent circuit is obtained. Here we connected both current source, which is 1 ampere, and resistance, Norton resistance, which is 2 ohm, are connected in parallel. This is a Norton equivalent. Now we find the load current in the next step. In step 5, the Norton equivalent circuit is added with load resistance. This circuit is shown in the following figure. Here we connect the load resistance which is 3 ohm connected with Norton equivalent. We know that the Norton equivalent 1 ampere current source and 2 ohm Norton resistance. Here we apply the current division rule to find the value of load current. Load current is flowing 3 ohm resistor. Simply apply the current division rule. IL is equals to 2 ohm into 1 upon total resistance. Total resistance is 5 ohm. Now we find the 2 by 5 ampere, which is flowing 3 ohm. If anybody asks, please find the load voltage VL, so we use simply VL is equals to IL into load resistance. So it is 2 into 3 upon 5, 6 upon 5 volt is the load resistance or load voltage value. Now I am giving 2 questions for practice. In this circuit, 3 ohm is a load resistance. To find the IL, in 3 ohm resistance. In second circuit, to find the IL in 3 ohm resistance. Here difference is only in the question 1, here we give voltage source, and second question here we give current source. Okay, if you have any doubt, any question in your mind, so please ask me, feel free. Sources and references. The material present in this lecture has been taken from the internet sites and books. This can be used for academic purpose only. Thank you very much.